Welcome to English Learning Podcast, Throw Science.
Today, we're jumping into something straight out of science fiction, really. Teleportation.
Yes.
You've seen it everywhere, with
Right.
like a Captain Kirk beaming down, superheroes just blinking across a city.
Instantly there.
Exactly, instant travel. From A to B, no journey in between. That's kind of the dream, isn't it? The ultimate shortcut.
It totally is in pop culture, definitely.
Mhm.
But here's the really interesting twist. While it feels like pure fantasy,
Yeah.
scientists they've actually managed a version of it, a form of teleportation.
Seriously?
Yeah. So our mission here in this deep dive is to sort of slice through that sci-fi image
Okay.
and really explore what teleportation means in science. Like, how does it actually work at that, tiny quantum level?
Right, the nitty-gritty.
Exactly. What are the limits right now? Because, spoiler, we're not beaming ourselves anywhere yet.
Ah, okay. Figured that.
And, what could it mean for the future? Think of this as your quick guide to understanding something that's, well, frankly, much weirder and more real than you might think.
Okay, I'm intrigued. So if the common idea is, vanish here, appear there, what is the scientific definition? What have scientists actually done?
Well, yeah, scientifically, it's a lot more subtle and maybe less dramatic than just poofing into existence somewhere else.
Uh-huh.
The really surprising thing is scientists have successfully, quote-unquote, teleported very small things. We're talking tiny particles.
Like atoms or smaller.
Even smaller, usually photons, particles of light. And they do this using a process called quantum teleportation.
Quantum teleportation.
Okay, that's the key scientific term. And crucially, it's not about the actual particle, the photon itself, physically zipping across space.
Wait, okay, hold on. My brain's already buffering. If the particle doesn't move,
Yep.
how is that teleportation? How does that even work?
Huh. Yeah, it's definitely counterintuitive. That's the core of it, really.
Right.
The basic idea is you're not sending the thing. You're sending the information about the thing.
Information.
Exactly. The particle's state, which is like its precise condition, its properties, maybe its spin or polarization,
Okay.
You send that information to another place. And then at that destination, another particle, an identical one, is basically prepared or created in that exact same state.
So you're like faxing a particle, but quantum style.
That's actually not a bad analogy in a way. You're sending the blueprint, not the building materials.
But how? What's the mechanism? This still feels like, well, magic. How do you send the state without sending the thing? What connects them?
Ah, right. This is where it gets really, really weird. It all hinges on something called quantum entanglement.
Okay, I've heard of that. That's the spooky action at a distance thing, right?
That's the one, Einstein's famous phrase for it. Imagine you have two particles, like our photons, and they become linked, deeply linked.
How?
So linked that they essentially share the same existence, the same fate, no matter how far apart they are. Miles, light years, doesn't matter.
Seriously. Instantly.
Instantly. If you measure something about one particle, like its spin, you instantly know the spin of the other one. It's like they're communicating faster than light, though it's more subtle than that.
Yeah.
It's a correlation.
Wow.
And this isn't just theory. It's been proven in experiments over and over. This bizarre, instantaneous connection is what lets you transfer the information about one particle's state to its entangled partner far away.
So you measure the first one, which involves the entangled partner.
Sort of, yeah. You perform a special kind of joint measurement on the original particle and one member of an entangled pair. This destroys the original state. But the information needed to recreate that state pops up over with the other entangled particle. You just need some classical information sent over like an email, basically telling the person at the other end what measurement was made so they know how to tweak their particle to match the original.
Okay. Entanglement is the key. So if we can do this with photons, these tiny particles, why can't we teleport, I don't know, this mug? Or me? What's the roadblock? Is it just technology or something more fundamental?
Right, the big question. And yeah, that highlights the massive limitations we have right now. Quantum teleportation, the way science does it, really only works reliably for single, simple quantum states, like one photon.
Not trillions and trillions of atoms.
Exactly. Think about a human body. Trillions upon trillions of atoms, all interacting, all with their own complex quantum states, scanning all of that perfectly.
Seems impossible.
The amount of information would be astronomical, beyond anything we can currently conceive of handling. And then you'd need to reconstruct it perfectly at the other end. The energy requirements alone would be, well, unthinkable with current or foreseeable tech.
So practically it's a non-starter for people anytime soon.
For people, or even complex objects. Yeah, it's firmly in the realm of extreme long shots, if not impossibility based on how we understand it now. And then there's that other angle.
The ethical one.
The philosophical one, yeah. If the process involves scanning you, which likely destroys the original.
Destroys me.
And then creates a perfect copy somewhere else, atom for atom, quantum state for quantum state.
Yeah.
Is that copy still you?
Whoa. Yeah. Does your consciousness transfer? Is it just a perfect replica walking around thinking it's you?
Precisely. It gets into deep questions about identity, consciousness, what makes you you. It's a fascinating thought experiment.
Definitely something to chew on. But okay, setting aside the existential dread for a moment.
Good idea.
Even with these huge hurdles for like human travel, what do scientists see happening with this tech? Is it just a lab curiosity or are there other applications?
Oh, absolutely not just a curiosity. While beaming people around is likely sci-fi forever, quantum teleportation itself, that has huge potential.
Like what?
Think about communication, secure communication. Because of how quantum states work, if someone tries to eavesdrop on a quantum transmission,
They mess it up.
they inevitably disturb it. The very act of observing changes it. So you'd know instantly if someone was listening in. It could lead to truly unhackable communication networks.
Okay, that's big, like for banking, military, everything.
Exactly. And also computing. Quantum computers, which harness these weird quantum effects, could potentially solve problems that are impossible for even the best supercomputers today. Quantum teleportation could be a key way to transfer information within those quantum computers or between them.
So it's more about secure data and superpowered computing than travel.
In the foreseeable future, absolutely. It's about revolutionizing how we handle and process information, fundamentally.
It's easy to think it's all just theoretical, tiny scale stuff. But you mentioned earlier they have made progress. How far have they actually managed to teleport this quantum information?
Yeah, there's been some really impressive progress on distance. Get this. Back in 2017, Chinese scientists pulled off something pretty amazing. They successfully teleported the quantum state of a photon, that information we talked about, from a ground station all the way up to a satellite in orbit.
A satellite? How far is that?
Over 1,200 kilometers.
Wow. Okay, that's not just across a lab bench.
Not at all. 1,200 kilometers. That's the record so far for quantum teleportation distance. It was a massive proof of concept.
What does that prove, practically?
It proves that transmitting quantum information over very long distances, even through the atmosphere and space, is actually feasible. It's a huge step towards things like a global quantum internet, that secure communication network we mentioned.
So, putting it all together for someone listening, try and wrap their head around this. We started with Star Trek.
Right. Fun, but not reality.
And found out scientific teleportation is really about sending information about tiny particles using that weird quantum entanglement link.
Exactly. The state, not the stuff.
And while teleporting people or, coffee mugs is incredibly difficult, maybe impossible, due to the sheer scale and that whole "is it still you" question.
A very big hurdle, yes.
The underlying quantum teleportation tech itself is real. It's progressing, like that 1,200 kilometers satellite experiment, and it could actually change the world.
It really could. Think secure communications, revolutionary computing power.
So at the end of the day, what should you, our listener, take away from this deep dive?
Well, I think the main thing is, while you probably won't be beaming up anytime soon,
Shucks.
the science itself, this whole field of quantum information, is pushing the absolute limits of what we understand about reality. It forces us to ask fundamental questions.
It's not just about travel.
Not at all. It's about information itself. What is it? How fundamental is it to the universe? What does it mean for two things to be connected instantly across vast distances? And yes, what does it even mean to be you?
Deep stuff.
It really is. So maybe the takeaway is that even if the sci-fi dream remains a dream, the science underneath is incredibly real, incredibly strange, and it's already starting to build technologies that could reshape our world in ways we're only just starting to grasp. It reminds you the universe is, well, a lot weirder and more interconnected than we usually give it credit for.